Okay, so welcome back to the second part of the problem on shear stress of an I-beam. So in the previous video, you can go through the previous video, we had discussed about all the different terminologies in the shear stress formula. Okay, so this is basically the formula for calculating shear stress, and we had also discussed how to calculate the moment of inertia for an I-beam. Okay, so now here in this video, we are going to directly go to calculate the shear stress at different points and at different sections. So first we have to calculate the shear stress at point B in the flange. So this horizontal component is my flange, and we have to calculate point B not in the web but in the flange. Okay, so let's check out how. Okay, now you know V. V is nothing but applied shear force, which is given as 50 kilonewton, right? You know I we had calculated it as 1.086 into 10 to the power 8 millimeter to the power 4. Now we have to calculate AY bar. What is AY bar? I will again write down what is AY bar. AY bar or AY dash, whatever you call it. It is the moment of area of the section above the point at which shear stress is to be calculated. So what does this mean? See, first you have to locate the point at which shear stress has to be calculated. So we have point B, we have to calculate the shear stress at point B, right? And wait, let me just erase this off. Okay, so this is my point. This is my point at which I require the shear stress. Now you have to consider the section, okay, above this point. So what is the section which is lying above this point? Above, not below. So this area of the flange, or this section of the flange, is the section which is lying above this point, and we have to calculate the moment of area of this section. Okay, so AY bar is going to be how much? AY bar is nothing but area of this section. How much is this area? It is 150 into 25. Okay, AY bar, Y bar is equal to 150 into 25. Okay, and what else? Into, what is Y bar? Y bar is nothing but the distance of neutral axis. It's getting disturbed. Okay, Y bar is nothing but the distance of neutral axis, okay, or the distance from the neutral axis of the centroid of this section. Okay, right? So where is the centroid of this section lying? The centroid of this section is lying, let me show you. The centroid is lying somewhere here. I will just show by a dotted line. This is the centroid of this smaller section. And where is my neutral axis lying? Neutral axis is lying at the symmetry. Okay, this is where my neutral axis is lying. Okay, let me show it in cream color. I think it's visible. So Y bar is nothing but the distance of the centroid of this section from the neutral axis. So this is going to be my Y bar. Okay, now if you calculate Y bar, how much is it going to be? How will you calculate? See, this part, okay, I will just annotate. See, you know, you can calculate this height. Okay, the total height of this web is 200 mm. So how much is this going to be? It is going to be 200 by 2, that is 100 mm. 200 by 2 is equal to 100 mm. Okay, I'm not writing mm. And you have the thickness of this flange, which is 25 mm. So how much is going to be half the thickness of this flange? 25 by 2. Okay, So this part, this height here is 25 by 2, or it is, I can write it as 12.5. Okay, so basically y bar is equal to 100 plus 25 by 2, that is equal to 112.5 mm. Okay, very simple. You know the area. How much is the area? Area is equal to the area of the flange that is above this point, or area of the section above this point, that is 150 into 25. So you multiply these two values, okay, and you will get how much AY bar is. Now as for the B, there is another term that is there, okay, which is B. How much is B going to be? B is going to be the width of the section for which shear stress is to be calculated, the width of the section at which the shear stress has to be calculated. So we are calculating the shear stress of point B in the flange. So the section under consideration here is the flange. So I have to take the width of this flange. How much is the width of the flange? It is equal to 150 mm. Clear? So you have all the values with you now, and you can easily substitute these values in the formula, okay, in the formula, and you are getting the shear stress at point B in the flange as 1.302 Newton per millimeter square. I would request you to do all the calculations by yourself, so that you can grasp it in a better manner, in a more simpler manner. Okay, now next what do we have? I will have to clear the drawings. Now next we have to calculate the shear stress at point B in the, okay, I've written it wrong. We have to calculate shear stress at point B in the web, right? This is going to be web. Web, okay? So you know the value of shear force, you know what is I. What will be B here? B is the width of the section at which shear stress has to be calculated. See, in the previous subdivision, we were calculating the shear stress in the flange. So we had taken the width of the flange. We had taken the value of B as the width of the flange. But now we have to calculate the shear stress in the web. Okay. So now you have to consider the width of this web, not of the flange, because now you're calculating the shear stress of the web. So here value of B in this case is going to be how much? 20 mm. Okay. This is the width of the web. Right, let's see. So we have substituted with 50 kilonewton. I is 1.08 into 10 to the power 8, and B, that is the width of my web, is how much? Width of my width of web, B, is equal to 20 mm. Okay, next thing what you have to do is, you have to calculate AY bar. Now see, this value of AY bar is going to be the same as the previous case. Why? Because the point, we are still calculating the shear stress at this point B. The point B is same. Okay, we are simply taking the different section. We are simply calculating the shear stress for a different section, that is for the web. But the point B is remaining in the same position as it was for the previous part. Okay, so what is AY bar? AY bar is the moment of area of the section which is lying above this point with respect to neutral axis. So the section which is lying above this point B is only this flange portion. Okay, so there is nothing new in the calculation. You have to, if you take the previous calculation, that is the calculation of AY bar of the flange section above point B, okay, that is the same value the same thing you have to do it for the subdivision B also, for calculating shear stress at point B in the flange, because my section, the point is not changing and the section above the point is also not changing. It is the same. Okay, so AY bar will be equal to 150 into 25, which is the area of the flange, into Y bar is going to be the centroid of the flange with respect to neutral axis, that is this part is going to be 112.5. so it is coming out as 4.218 into 10 to the power 5. Substitute all the values in this expression and you are getting the value of shear stress at point B in the web as how much? 9.76 Newton per millimeter square. I would request you to do the calculation and check the values. I might make a mistake. Okay, so I think it is clear how to calculate the shear stress at point B for both flange as well as web. Okay, so I'm going to end this video here because it is getting longer. In the next video, we are going to calculate the shear stress at point C and we are going to see how the shear stress distribution will be for the entire beam.